bit of recollection. Last class we had spoken about good absorbers. So we studied that black color is a good absorber of heat, right? Good absorbers. And a little bit of recollection if you want to understand radiation. We're studying about radiation. Radiation is the mode of heat transfer from one body to another body, in which there is no medium of transfer needed. Like you don't need an air, or you don't need, it can travel to vacuum. So one of the main reasons, or the thing which impacts radiation, is infrared. And infrared radiations are actually electromagnetic waves, and electromagnetic waves do not need any sort of a medium. We have seen that. Sunlight reaches to us all across space. How sunlight reaches us all across the space? Because sunlight breaks all barriers and comes through vacuum. So infrared radiations do not need any sort of medium to transfer. This mode of heat transfer is known as radiation. Also understand, when an object is hot, the object will, if it is very hot, it will also emit ultraviolet, and it will also emit white light along with it. But the heat that we sense from a hot object is mainly due to infrared radiations. Okay, we spoke about good absorbers. So out of all colors, we said that black is a good absorber. And what was the example we took? We had a heating element, both sides covered with tin. One side it was only tin, and the other one we had, what do you call, painted black on the inner surface and fixed coins with the help of paraffin. And we found that the one which had a black on the inner surface, the paraffin melted first, showing that that surface actually absorbs more of heat. Today we are going to talk about emitters. Okay, good and bad emitters. We're going to talk about good, and we're going to talk about bad. Good and bad emitters. Also, we spoke that when sunlight reaches the earth, a part of that sunlight is absorbed, a part of the sunlight is reflected, and a part is transmitted. We are talking about emitters now. Now, for this also we have a sort of an example. What we do there is that we actually take again a copper plate. Okay, we take a copper plate. Let's say, sorry. So the copper plate is taken in this manner, and this is a heated copper plate. Okay, this is a heated copper plate, and one side of the copper plate will be made dark, and one side of the copper plate will be left like that. Okay, so we have made one side dark. Now this is a hot copper plate. So in order for you to understand, let's say this surface we have made dark. Are you able to understand? This is the copper plate. There are two surfaces to it. One side has been made dark. Okay, it's that the example is there actually given. One side has been blackened, and the other side, one side with one side polished, and the other side has been blackened. Now there is an interesting thing. This is hot now. Let's say this side has been blackened and the other side is polished. Now if you bring your hands and close your eyes and bring your hands on either side of the plate, this is hot. You will find that the blackened side, you are sensing more heat in your hand. Now this is contrasting from what we studied. Yahan thoda dhyan dijiye. In the earlier example, we studied that a black surface absorbs more heat. That surface was actually not a heated body. It was a body at normal temperature. Now this surface is extremely hot. And what did we do? When we have made it extremely hot, we have made one side black and one side polished. Close your eyes so that you don't get biased and you don't know which side is what. And suppose somebody holds your two hands and tries to bring it so that you don't burn your hands, then you will find that the heat on the black side is more, which gives us another one understanding that anything which absorbs heat, okay, we have a body, and this body absorbs heat. So what do we call it? Good absorber. This was what we studied in last class. A body which absorbs heat is called a good absorber. If this good absorber itself is also hot, this will also emit radiation. Do you get it? And it becomes a good emitter. Yahi se aap padhte ho that black body radiation, which you understand, this is radiation. A black body absorbs heat when it is brought near a hot object. And when the black body itself is hot, it will also emit radiation. Radiation means, out here we are talking about IR only. So it's a good emitter of heat. And that was precisely as we were ending our class, I was giving the example that the refrigerators of old days, which has grill outside, they are actually supposed to absorb and emit. So they are black in color. Are you getting it? They're black in color. So far, what all you have read, you have studied about radiation. Okay, just check yourself if you need any explanation. We covered about radiation, and in order to understand radiation, you had to understand IR. So we covered the concept of EMS, the electromagnetic spectrum of the sun, where you should also know that all you are talking about was ultraviolet, then the light range, and then infrared radiation. We are discussing everything in this part. And the wavelength, if we talk about wavelength, then the wavelength increases as you go this side. And if you talk about frequency, then the frequency decreases. Okay, how to understand frequency at this level? Frequency is like intensity. More is the frequency, more is the intensity. For example, beyond ultraviolet, we have got gamma rays. They have more frequency, so more intensity. They can penetrate concrete also. Then comes X-rays. And at last we get radio waves. Radio waves have high wavelength, but low frequency. They can't travel long. They can travel, but their penetration power is less. This we will utilize again in a little bit later in one of the discussions. So do you understand? Now just check. Do you understand radiation as a mode of heat transfer? Do you understand the electromagnetic spectrum of the sun? And the part of sunlight which is actually responsible for radiation is the infrared rays. Always remember, infrared rays is responsible. After that, we understood that once radiation happens, how do bodies behave towards radiation? So we found that a dark body absorbs more heat than a body which is shiny. That's one of the reason I gave that, cars in Delhi and all, they will always, when they park their car outside, they will have a shiny piece of a small layer, which is like a rolled cloth, not a cloth, it's like a mat, a shiny mat, which they will put it on their windscreen. So whatever the shiny ones reflects it, they don't absorb. So the car does not get heated up. So one which absorbs heat is known as a good absorber. And what we understood, if a good absorber is itself hot, it is also going to emit radiation. And so it's a good emitter also. This concept is clear. Now, two more things we'll understand: temperature and rate of emission of radiation. Okay. Our next part. Shall I go ahead? Our next part is temperature, and these are very easy topics. You just need to understand the logic. Temperature, and it's about temperature and the rate of emission. The rate of emission. Now, everything that we are talking is in terms of body releasing heat. Emission means body releasing heat. Body is not absorbing heat. Okay. Now, tell me, do you know the concept of absolute zero? Absolute zero means 0 Kelvin. Any body which is above absolute zero emits radiation. Simple. Any body is clearly written. They say radiation is emitted by all body which are above absolute zero. So if you are above absolute zero, you are going to emit radiation. Now, absolute zero, this is 0 Kelvin. So any body above 0 K emits radiation. And if this body is hot, then it will give you UV, IR to dega hi dega, plus it will also give you light. Right? Now we are going to talk about temperature of a body. Now just see. Now let's say this is a body. This is my body. What we are trying to study in this section is the temperature of this body as the body is absorbing as well as emitting. Are we clear on this? So just look at it. It's very easy. If your average rate of absorption is more than average rate of emission, the temperature will rise up. Heat बढ़ गया. एकदम easy concept है. If your average rate of absorption is more than what is, just like eating, and if you eat more and you exercise less, you're going to swell up. And if you are going to eat less and burn out more, you're going to slim down. So we say if the average rate average rate of absorption is greater than the average rate of emission, then what happens? Body temperature will come down. Is this logic understood? Average rate of absorption of radiation. See, we are not worried about out here, we are not worried about conduction, convection. Imagine that the only mode of heat transfer is radiation. In that scenario, if a body absorbs more radiation than it emits, its temperature is going to, I wrote the wrong thing. Sorry. The temperature is going to, body temperature is going to go up. Are we clear? ये लिख लीजिए, इसका converse भी लिख लीजिए. That's the reason if you wear a dark cardigan or if you wear a dark pullover or if you wear a dark sweater and you go out, in say in winters, the moment the sweater starts absorbing, its absorption rate is more. Black है ना, रिलीज करेगा धीरे धीरे. वो रिलीज क्यों धीरे करता है वो हम देखेंगे टेक्निक, how it is made, because we have understood that anybody who is a good absorber is a good emitter. So how do you cancel the emission and yet keep your body cool, warm? That we will see. So if the average rate of absorption is more, and conversely we say if the average rate of absorption is less than the average rate of emission, then the body temperature decreases. The body temperature will fall down. So now tell me, to maintain constant temperature, what is needed? To maintain constant temperature, what do you think you need? So for that, the absorption rate should be equal to the emission rate. These are the challenges that designers have when they are designing things for specific purpose. If you want the temperature to be constant, absorption rate should be equal to the emission rate. Right? So we started our discussion today with what? We started our discussion today first with good emitters and bad emitters. So you have understood what is a good emitter and what is a bad emitter. How did that discussion start? We said that any body which is hot will always emit radiation. Hot means, and very hot objects like sun and all will also give you ultraviolet and light also along with infrared. So the dark surface, if it is cold, absorbs more. The dark surface, when it is hot, emits more. Okay? And then we saw what is the temperature relationship of a body with the rate of absorption or rate of emission, which is a pure mathematics, and in order to remain constant. Now we go to one more topic, which is called greenhouse effect. Or greenhouse effect could be, though you must be knowing about it, but let's understand once again the greenhouse effect. I don't know how many of you know, you might be knowing the greenhouse effect actually comes from the word called the glass house effect. Okay, ये actually greenhouse बोलते ही हमें लगता है, environment pollution and degradation. Not like that. Actually, it was not that. The glass house effect is a good thing. So it comes from the concept of glass house effect. Glass house effect. So when the demand for growing more crops came up, and temperature was not supporting you, especially in cold countries, temperature is not supporting you. Extreme cold temperatures also will not allow you to grow crops. So let's understand first what is glasshouse effect. Book does not talk much about it. They speak about greenhouse effect. So in glasshouse effect, we typically have a glass enclosure. We have a glass enclosure. It's completely like a cuboidal glass, right? And it's in cold countries, okay, where temperature is very cold, and your plants need little bit amount of a realistic temperature to grow, but that temperature you are not getting. So what happens? Those plants are grown inside a glass sort of a cabinet, thinking that when sunlight falls on it, when sunlight is falling on it, the sunlight gets trapped within that. Imagine that this room is made up of glass. A very common example, put yourself in a car parking on a summer day and roll up all the glass panes. Don't you feel hot? It's the same impact. But this was done for good. Good means the plants could grow at that time. They trapped that heat and they could grow. Now this concept was extended as greenhouse effect. So we'll see what it is. Have you understood what is glasshouse effect? Because it's for general knowledge, okay? Now, same concept, Once now the question now arises for us is, we go back to glasshouse effect. We say that if there has been absorption. Now what happened actually? Exactly, there was radiation and there happened absorption of radiation happened. Do you agree or not? That's why the temperature of the enclosure went up. But we studied that when there is an absorption and a body who absorbs, a body should emit also. So there should also be emission. Agreed or not? There should also be emission. So here, how is that the temperature is rising? Which gives us one conclusion, that maybe the rate of emission is not that much as the rate of absorption. That's why the temperature rises. Now here there is a catch that you should understand. The catch is that if you see the infrared radiation, then the infrared radiation is also in a band. It's also in a band. After infrared radiation, what do you have on this side? Visible light. Then what do you have? You have the ultraviolet radiation, UV. Okay, this is your light. The infrared radiation also comes in a band. If you are getting the infrared radiation from very hot surfaces, example sun, then you are getting the infrared radiation from the shorter wavelength part. Okay, try and imagine, what did I say? The wavelength increases. So infrared radiation on this side will be of short wavelength. This infrared will be of larger wavelength. So here, what do I say? Wavelength, I was denoting wavelength with the word lambda. So I'll keep denoting with lambda. The wavelength in this side is short, which means the frequency in this side is more. This is the infrared radiation that is coming from an extremely hot body like sun. Its frequency is more, its wavelength is less. So your book does not talk about frequency. Your book will say short wavelength. Your book will say short wavelength IR. And short wavelength IR comes from very hot objects like sun. Have you understood? But to understand it properly, short agar wavelength hai, then the frequency is high. If the frequency is high, the stamina of this radiation is very much. ये glass को आर पार करके अंदर घुस जाता है. So what are you getting here? We are getting short wavelength IR. We are getting short wavelength IR. Have you understood? And when these objects which are inside, like say soil or plant or saplings and other things inside this glass box, so these are also emitting radiation. Now these emissions that they radiate from inside are actually long wavelength infrared radiation. Means they are emitting IR out somewhere here. Here the lambda is more, so the frequency is less. So their radiation does not have that much power to break the glass and get out. Instead remains trapped. Have you understood? Infrared radiation is not one particular frequency, it's a band. When sun sends infrared radiation, it is sending infrared radiation of short wavelength. Short wavelength means, I told you, this is this electromagnetic spectrum of the sun. Like this side we have got gamma rays and this side we have got radio waves. Okay, this is the entire spectrum. I told you wavelength always increases as you go from this side to this side. This is how the wavelength behaves. But frequency falls down. If the wavelength has to go, the frequency has to fall. Now here you are getting shorter wavelength. Means the frequency of this part is more than the frequency of this part. Both are IR radiations, no doubt about that. So if the frequency is more, the penetrative power is more. And this belongs to whom? Suns. These are the IR of the sun. You all are silent. Are you understanding? Because there is no, I don't see any facial expression like yes or no.
IR different than the one that goes and comes out.
तो इतना देर से क्या बोल रहा हूं मैं? That's why I say, children, it's a theory class. I try myself to keep calm. Theory classes cannot go on monologue. Your batch is the only batch who does not speak. I can go on speaking 1 hour on this topic. What is the point if you don't answer? If you don't, at least you have asked. I'm happy. I should not be angry. If you are understanding this stuff, because in your book, these diagrams won't be there. Your book will use a word called short wavelength. Please understand, our radiation is a band. It's a band. A band means there is a range of frequency, there is a range of wavelength. Do you understand? You can, this is also IR, this is also IR. IR is not one frequency, it's not something like BBC radio, one frequency, one wavelength. IR is a band. When the sun is shooting infrared radiation, it is shooting infrared radiation of shorter wavelength. When the wavelength is shorter, the frequency has to be more because multiplication of both is the constant. Multiplication of lambda and f gives you the speed of light. So if you are getting this reduced to keep this constant, this has to jack up, right? 1 into 6. We have to get 6. If you are making this 6, then this has to become 1. We have to get 6 na end of the day. 6 is an example I'm saying. Are you understanding?
Yeah.
So the infrared radiation that comes from any infrared will make you feel hot. The question is, what is the frequency of that infrared radiation? Your book talks about what is the wavelength. It's same. It's just seeing the two sides of coin. The wavelength of the infrared radiation that you get from sun is a shorter wavelength. Means sun यहीं से मार रहा है आपको. तो इसकी frequency ज़्यादा है. ज़्यादा means this particular radiation has more penetrative power to break the glass barrier and get inside the glass coffin where your saplings are growing. Have you understood? अब वो saplings ने absorb कर लिया. Anyone who absorbs should also emit. यही तो हमने पढ़ा. अभी अभी हमने क्या पढ़ा? Any body whose temperature is more than absolute zero should emit radiation. So these poor saplings, earth, gravel, whatever you have, plant up, they should also emit radiation. And if they are emitting radiations, then why on earth do you say that this is warm? This is warm means the heat is trapped inside. That means either they are not emitting radiation or the emission rate is lower than the absorption rate. Simple mathematics. Either they are not emitting or their absorption rate is more than the emission. That's not the story. They are emitting. But that emission is coming in the form of infrared radiation of larger wavelength. Because unki heat itni nahi hai. Are you understanding? If you make a karhai hot today, not that hot, somewhat hot, or say a cup of tea is also emitting IR. But that IR is in this range. Its frequency is less, its wavelength is more. That IR will make you can sense hot. You will say, sir, चाय का कप भी तो मुंह के पास लाने से गर्म लगता है. Barrier नहीं है. But if you put a small, say, your protector or something, or your glass, one piece of glass, and you keep the cup of tea here, आपको चाय के कप से गर्मी नहीं लगेगा. आप समझ रहे हैं बात? Because the radiation of that tea cup is comprising of large wavelength IR rays. And large wavelengths do not have penetrative power. So what happens? Their emission is unable to get out. As a result, what has happened? The equilibrium has been disturbed. आप ज़्यादा खा रहे हो, छोड़ नहीं पा रहे हो. So the temperature inside this glass house increases. This is the glass house effect. Similarly, if one greenhouse effect, what do we study? In greenhouse effect, we just say one thing, that we have got our planet Earth, and out on this planet Earth, because of your industrial pollution, typically burning of fossil fuels, you have actually made a layer of methane and carbon dioxide. Any sort of fossil fuel that you burn is a methane or carbon dioxide. Now this is also behaving like a film. But this film cannot prevent sun rays to come inside. गर्मी तो आपको लगेगा. Now the earth has got heated up. The earth needs to emit its radiation. At that time, the earth's radiation is of large wavelength. Always remember. Sir, who all emits short wavelength? Very, very hot object. Very, very hot object, which is in the range of sun. The sun's temperature is 6,000. It's very hot. So the earth is also radiating now. What is the earth radiating? The earth is also radiating IR. But these IR are of large wavelength. बड़ा lambda. So इनका frequency क्या हो गया? Low हो गया. They are unable to get across this gaseous layer that you have created. As a result, you are suffering from something which is known as global warming. The earth has got heated up. Average temperature of the earth has gone up. Glaciers are melting. Water level is rising. The only positive part, Greenland is increasing its tourism. वो भी अच्छा है. Do you know the good part of global warming? Greenland is having tourism. Greenland never had tourism. Now Greenland is attracting a lot of tourism. Ireland is having tourism, Iceland is having tourism. These places people never used to go and visit. ठंडी इतना ज्यादा है, अभी ग्रीनलैंड लोग जाते हैं. वहीं खराबी क्या है? मुंबई वाटर लेवल इज गोइंग अप. There are four what you call islands like Karabati and all. You know, have you heard about Fiji? Okay, in the Oceania group, from Fiji, there are 4-5 islands out there. Nauru, Fiji. There are two islands which are supposed to go down now. They will go inside. नीचे चले जाएंगे वो सब. Clear? Anyone who has not understood can ask a question. If you have understood, then it's very good. Our last thing is now rate of cooling of an object. So rate of cooling is greenhouse effect understood, is glasshouse effect. Your book only talks everything with this glass, does not use this term called glasshouse. I thought it's better you should understand the glasshouse effect also. So whenever the story is very simple, in a glass house, the absorption will happen because absorption is happening due to sun rays or IR from the sun hitting you. And IR from the sun comes from shorter wavelength, and shorter wavelengths can penetrate. But when you start emitting, you are not that hot. So you emit what? You emit large wavelength. Large wavelengths do not have the power to penetrate out. As a result, the heat that you are emitting is remaining trapped inside, which is good for growing fauna, but not good when you extend this concept to the earth. ठीक है? Our next topic is very simple. Rate of cooling of an object. कुछ लिखना है तो लिख लीजिए. I'll wait. And if you want to ask anything, you can ask. And radiation will also follow the same law of heat transfer. Heat always transfers from what? Hot object to cold object. देखो जब radiation पढ़ रहे हो, don't forget that potential, which I always say. Current flows from higher potential to lower potential. Water flows from height to this. Heat will always flow from higher temperature to lower temperature naturally. If you want the heat to go this way, you need a heat pump, which is like your refrigerator or which is like your AC. You have to burn energy because that's against. So we are talking now about rate of cooling of an object. I'll just discuss it, nothing great. So let's say the rate of cooling of this mouse. If this mouse is at a higher temperature than the surroundings, this mouse is going to release heat. Obviously, this is going to. If this mouse is at a lower temperature than its surroundings, this mouse is going to absorb heat. We are talking only in terms of right now radiation. So keep that radiation mindset in your mind. If the mouse is at a temperature which is more than the surrounding, then the mouse is going to release heat. And if the mouse is at a temperature which is less than the surrounding, the mouse is going to absorb heat. And this goes on till the equilibrium is achieved. If it cannot, now you might say, sir, I brought a mouse right from the refrigerator at -24 and today it is very hot and I kept it. You said that it should go on absorbing heat and it should get heated and the room should get cooled till equilibrium is achieved. My dear boy, equilibrium can be achieved till it can go on absorbing heat. ये कितना और absorb करेगा? एक टाइम के बाद ये और absorb नहीं करेगा. The room is much more heat. So instead of this mouse, if you have bought planks and planks of ice and if you have kept it out here, तब हो जाता, कोई issue नहीं. In fact, if you see videos of some places like in Alaska and Siberia where water becomes scarce, people have blocks of drinking water in the form of ice and kept in the house. वो melt ही नहीं करते because outside temperature is much more cooler. Are you getting it? So the ice blocks remain. So it says, as a result, cooling until the two rates become equal and a constant temperature is reached. The higher the surface temperature object than its surroundings, and the larger the surface area, the greater quantity of emission it will emit. So this is one thing which I wanted to touch. So what I said, one is this object is at a higher temperature. Another is this object is at a higher temperature plus a more surface area. Imagine yourself a pin made very hot and brought near your skin, not touched. Do you feel more hot? Or a plate which is made hot and brought near your skin? The plate. Because the plate not only is hot, has a more surface area. So greater the surface area, more. It's simple. Your mom pours khichdi to you, two bowls, just one above the other. 2 helpings, it's not going to cool down quickly. So what do? You increase the surface area. With a spoon, you just spread the khichdi. So it's hot, plus you have increased the surface area. So it cools down easily. Clear? That's all about radiation. Nothing more. So what are the salient points you should know in this chapter? First is, what is radiation as a definition? And the key hot words that we use in what is radiation is no involvement of any medium, and heat gets transferred from one body to the other body. That is like a kiddo definition. How did the heat get transferred, sir, if there was no medium? Well, that heat was comprised of an electromagnetic radiation called infrared radiation. And infrared radiation is a part of the spectrum of the sun. So one of the example that comes, can you give an example of radiation? Earth getting heated by sun. Sun is releasing radiation in the form of the entire spectrum. In that spectrum, the IR part is one which is heating up the earth. And a body, when it is too hot, it will also emit light and ultraviolet rays. Right? This was about sun and the earth. After that, we wanted to understand what is an absorber and does color play a role? We found that yes, dark colors are good absorbers. They absorb the IR component more. What was the proof of it? We had a tin sheet, one side made dark and one side was just left like that, and we affixed 2 coins with the help of paraffin, and we kept them at an equal distance from a heating source, and we found out that this one which has its inner side black, that paraffin melted quickly and the coin fell down. So we understood what is an absorber. After we understood what is an absorber, we again took a copper sheet and made one side dark and one side we kept it polished, that is shiny. And then what did we do? We heated the copper surface now. And then we brought 2 neutral surfaces of our hand by closing our eyes, and we found that we are sensing more heat from the dark surface, which means a dark body which absorbs more heat, when it is hot, it is also emitting IR radiation, and it's a good emitter. A dark body is a good emitter. Do not confuse it with the shiny surface. A shiny surface is a good reflector. A shiny surface is a good reflector. That was the example which we gave for the front screen or the windscreen of the car. The mat which people put, rather than, why did a person not put a black carpet out there? If he puts a black carpet, it's going to absorb more and more. Gaadi aur garam ho jayega. Rather, he puts a shiny one. Chala jata hai bahar. ठीक है? Then we understood good absorbers, good emitters. Okay, good and bad absorbers, good and bad emitters we have understood. And any body whose temperature is more than that of absolute zero is going to emit radiation. This brings us to understand now what is the impact of temperature versus the rate of emission. So if the rate of absorption is more than the rate of emission, because we know that any body, when it is hot, it is hot matlab kya? आप एक body के पास, you're going on putting heat to it. So the body is getting heated. Once the body gets heated, the body should also emit. So if the rate of absorption is more than the rate of emission, then the body's temperature rises. If the rate of emission is more than the rate of absorption, body's temperature. This is typically what happens in the land and sea breeze at night also. Land, will emit the heat much more quickly. That's gone. That brings us to the concept of greenhouse effect and glasshouse effect, where we understood that if IR is causing heat, then IR itself also comes in 2-3 varieties. Short wavelength IR, large wavelength IR. If the IR is of short wavelength, then the frequency is more. That is the way to remember it. That means it has more strength, more penetrative power. Which all bodies give such IR? Extremely hot body like the sun. Therefore, the sun's IR can penetrate any layer, a glass layer. But objects inside a glass body, when they become hot, they are also emitting IR, but that IR is of large wavelength. Their frequency is less. So they cannot penetrate that particular block. As a result, we achieve the heat that we want for growing fauna in a glass house. Whereas when it comes to the earth, that same phenomenon backfires on us. Due to the use of fossil fuels, we have created a layer of methane and other gases. And they have formed a layer which cannot stop the short wavelength IRs to come to us. So we get heated. But when we start emitting radiation, or we want to emit our radiation, they do not allow this radiation to get out. As a result, the earth heats up. And then we came to the last topic, which is rate of cooling. How do you cool? You cool if you are more hot than the surroundings, obviously. From a rich man, money goes to poor person. So if you're more, your temperature is more, you will lose more heat. And your temperature is more and your surface area is also big, you're going to lose heat much more quickly. You're going to cool down much more. Okay? The last part is consequences of thermal energy transfer. This brings us to the last section, that is consequences. This is absolutely discussion. Consequences of thermal energy transfer. So the first one is uses of conductors. Okay, uses of conductors, uses of insulators, and then we see energy losses from building. This part is taught in little bit, all the examples that they have given, it might initially become difficult for you to understand because these books are written for cold countries. So the examples are more cold country specific. The examples that they are talking, you don't see them in daily life in your part, because here the temperature does not go. So in your house, if they say observe in your house, आपके house में ढूंढने से भी वो सब नहीं मिलेगा. ठीक है? So use of conductors. Where do you need conductors? So common question. First paragraph talks about use of conductors. You tell me, where do you need conductors? Where you want heat to conduct quickly. Metallic saucepan. If you look at a saucepan inside, shiny surface कर देता है. ठीक है? So there the heat has to transfer more quickly. Insulators will be needed where the heat should not transfer. So it says that whenever heat is required to travel, then saucepan, boilers, other things are all made up of good conductors. And then wherever you don't want heat to travel, then you need insulator. Now, when this insulator talk comes, we are going to discuss about this particular item called air. ये चीज कुछ means get into your mind absolutely properly. Air is the worst conductor. That means air is the excellent insulator. Air is a very good insulator for heat, okay, as well as for electricity also. So air is a excellent insulator and air is a worst conductor. लेकिन देखो हमारे माँ बाप लोग क्या बोलते हैं, बच्चों बाहर मत जाओ, हवा से ठंडा लग जाएगा. इससे उल्टा है ना. Air is a worst conductor. Air is an excellent insulator. Any object which can trap air, are you understanding? Air is like a bad boy. Anyone who befriends a bad boy is going to be another bad boy. So all objects which actually trap air, what are those objects? Wool, fleece, है ना? All these trap air. So if they trap air, they will be equally worse conductors and good insulators. Have you understood? That's why we'll understand something called lagging. ये lagging word यूरोप में बहुत common है, आपको समझ में नहीं आएगा. Lagging is when houses are made in Europe, between two walls, gap will be left. That gap is because of what? To trap air. Europe gets very cold, and the cost of energy has now gone up like anything. Plus, the entire Europe has made Russia their enemy now. So, if you know a little bit of geopolitics, then Russia is the only country which is going to give you gas. Otherwise, you're going to die in winters. So, Germany is very nicely now a little bit backdoor. They are friendly with Russia. Russia gas नहीं देगा तो आप तरफ तरफ के मरोगे. ठीक है? So, they will have walls. And the walls will be put up with lagging type of material. Lagging is like, have you seen your AC duct pipes? What do? We cover them with a muff, okay? Felt muffing or felt or other materials. It's something like if you tear open a mattress, the type of sponge type of things which you get, fleece and other fibers. So those will be actually packed between the walls. So the walls are going to trap air, which is the bad conductor, and the air will be more attracted by these type of items. These are called lagging. Lagging देना बहुत जरूरी है. Lagging नहीं दोगे तो ठंड से मर जाओगे. Like Siberia and all countries, they will always something like this man is doing, like rolling up sort of a thing. So that's called a lag. Wool, fleece, and other things, and these lags are put up. Same thing happens in your wind cheaters and other things also. If you tear open a wind cheater with a small pen knife, you're going to see a light layer of fleece sort of thing. So wind cheater will have the air. Air is the contact between your body skin, and between the wind cheater, that felt will be there. So once it traps air, after that it is not going to allow any outside heat to get inside, cold to get inside. And your body, which has become warm, has actually, have you put on a jacket in a cold country or a cold place? First, the jacket will be very cold. After sometimes the jacket becomes very comfortable because the jacket inner surface has actually taken your body heat. So say let's say this is your arm. If this is your arm, then on your arm, you have now put the jacket. Now this part is with air, right? So initially by conduction, by sticking to your body, the jacket, this part has got heated up by conduction. Now, between two layers of your particular jacket, we will have the fleece part, which is going to trap air, and this is not going to allow this heat to get outside, or the cold. Cold cannot travel. Cold cannot travel. Heat should not go out because your body is hot. Outside is cold. So heat will generally go out from your body to the atmosphere. It will not allow it. That's how it. Diver suits. Diver suits get wet immediately outside. Once it has got wet, after that there is that small layer. So your body will actually heat up the diver suit from the inner side, and then your body heat won't be released outside. So these are some of the examples. So they might actually ask you a lot of questions like in terms of we'll see when we do papers, like some data, like this is a very painful problem in Europe, like as the cost of heating cost is very high. Like if you rent a house in India, what do we say? What are the utilities expenses? We say water, gas and electricity. So if you ask anybody in Moscow, what is your utility expense, they will say heating. Heating is a big cost out there, and the way you can minimize that is by energy efficient buildings. And if your buildings are not at all energy efficient, then what will happen? The moment you heat up the building, immediately the building will lose the heat. So you have to go on artificially heating your. So they use the air conditioners from both sides, even from heating the house. The heat should be preserved. If the heat is not preserved, cut off hona shuru ho jayega. Okay, then uses of convection. Now since you know these are very easy, convections, this is what you will understand well. Again, people who have stayed in more cold places like or I'll say in Ooty or say Delhi and all, we always have something called a convector. Have you seen a convector? A convector is like this much sort of an item, box sort of a thing, and it goes on blowing hot air. Everyone now, the sale of convectors will go up in Delhi. It started to get cold, so they'll buy that, they'll just plug it on, and evening when you come to the house, the convector is kept on. So what does the convector do? The convector goes on heating the air. So hot air rises up, cold air comes down, goes to the convector, again heats. But after some time, the convector means I cannot withstand. I feel oxygen gets depleted, but people who are habituated, they feel very comfortable. Like many people who sleep at night do not cover their feet. It's like a heater, but it's like a blower, hot air blower. Heater is a different thing. A heater will be something which is just heating. A heater just emits radiation. Convector is something which will be like your hair dryer. Have you seen? It's a big hair dryer, like a box. It will be kept in your house, and brrr, like a projector sort of a thing, and it will go on heating the room, which is needed. Otherwise, it will get very cold. It gets very cold. So places like Lucknow and all, if you don't have a convector like Chandigarh and all, it will be difficult for you to see. So convection uses also we have seen. And then comes uses of radiation, infrared thermometers. I don't think after COVID you need any example. Infrared thermometers are, we have seen a lot, the thermometers that we used to use during COVID. So what do? Your body is emitting an IR, and the IR is sensed by an electronic circuit calibrated to give you a particular scale reading. More is the IR, more will be the calibration. Okay? Some examples, like there are 3 examples which are given. I'll go by the easy ones. The wood or coal fire. Wood or coal fire. So how does wood or coal fire give you heat? Convection as well as radiation. If you are burning wood or if you are burning coal fire in your house, then how is the heat spreading in your room? Again, these objects, these are all written from coal country perspective, because you all are not habituated with this. Okay, if you burn coal or wood in a house, then you are having radiation, IR will come out, plus convection also. Air is getting heated up at the end of the day. Conduction does not happen. You yourself don't go and touch the hot wood. So there's no conduction. So if they ask you examples, the wood fire is an example of convection and radiation. Now come down to a thing called radiator. Radiator is a part in your car. So let's understand what all happens in a car. A car is run by its engine. The engine has all the firing which takes place. The engine becomes very, very hot. So the engine has to be cooled. So if So how do we cool the engine? We cool the engine by a fluid which is called a coolant. Coolants are also of two different types. If you take your car from here to England, the coolant that we use in India cannot be used in England. Why? Because if you take this coolant and you start driving it in some place like Germany, say you are in Hamburg the temperature will come down to say minus 13 degrees centigrade. So the car will show very nice. Outside minus 13, inside the car 21. So your coolant that you have taken from India will immediately freeze and clog the car. So the coolants available there are known as antifreeze coolant. Again, if you bring a car from Hamburg and you drive it in Dubai, that coolant सीधा evaporate हो जाएगा Delhi Dubai में आने से. So Dubai coolant will be different. India is we use either ready mix, concentrated coolants are available, or ready mix. The thing is, what this coolant does, this coolant will first be coming in contact. The coolant's property is that it can cool the engine. It will first come in contact with the hot engine. What is the mode of heat transfer? Conduction. Be very, very careful here. This is not convection. The coolant comes in contact with the hot engine. I've used the word contact with hot engine. So it's conduction. After conduction, this coolant will be moving. The temperature of the coolant will start rising. How does it rise? Convection. Temperature of the coolant rises by convection. And then the coolant will flow through the radiator. What is a radiator? A radiator is a sort of a heat exchanger. ऐसा होगा radiator. The coolant will come out from here and will get out from here. And the radiator fins are always made dark in color. Dark आप समझ गए ना? Emit. So पहले समझो, coolant is a liquid. As soon as the coolant will keep on circulating. The coolant goes and touches the engine, picks up heat by conduction. Then the coolant's temperature goes up by convection. And then the coolant is moving all across radiator, and the radiator का नाम ही है radiator, radiates. In 1960s and 70s movie, if you see, you'll see some scenes where the truck becomes hot and the driver will stop and he'll take a bucket of water and he'll pour inside. So those days we never had coolant. Water was used as coolant. But the problem is water's boiling point is 100 degree. Engine gets much more heated. तो पानी evaporate हो जाता है. कुछ देर बाद जाके, even ambassadors in 70s and all, you'll see people stopping in petrol pump and then they are pouring water in the ambassador. And the first water when you pour, it will just, therefore coolant should not, anyone who checks the coolant, you should not take your face like an idiot and start opening the coolant. If you do it, the coolant is going to splash out on your face. ठंडा होने के बाद coolant check करने का. और अगर radiator फट गया, like a front collision, you'll first see the entire green color liquid has come out of the car. A car runs on 5 different type of fluids. The fuel that you need, the engine oil to lubricate the engine, the transmission oil to lubricate the transmission system, the brake oil to take care of the brakes, the coolant, and the 6th one is the power steering fluid. These steerings of our car are power steering. There is a 7th one also, which is the windscreen washer fluid. 7 fluid चाहिए आपके गाड़ी में. Things are quite interesting if you see that way. Okay. The last one that we'll discuss is the vacuum flask. We all use it for keeping hot water cold. What is the thermos? Vacuum flask मतलब thermos flask. What is the use of a thermos flask? वो गरम वाला ही तो प्रॉब्लम है ना. गरम नहीं, उसमें ठंडा भी रख सकते हो. If you keep anything chilled, it will keep it chilled. If you keep anything hot, it will keep it hot. So how does that work? That has actually got inside the thermos flask. What you see outside is the plastic body that you see. Inside you actually have a silver flask, double walled, silver, shiny. So the only leakage you can have, and then you have your manufacturing jo aapka. If you see the IKEA one, then it will be green in color. So this is the green color flask that you buy from IKEA. And here you will have the stopper. The only leakage happens from here. Now let's see if we have poured hot water inside it. You have poured hot water. Now this is a shiny surface. What will it do? It will reflect inside only. And this surface is shiny. And in between there is vacuum. Vacuum means no heat can travel. So whatever something comes outside. Outside wala heat jo aayega, wo outside hi rahega. In fact, this is required when you are storing. This one will play its role when you're keeping a chilled or something chilled. If you're keeping something chilled, then the outside heat will not be able to attack it. And if you're keeping something hot, then the inside one is playing its role. Shiny surfaces. Shiny surface keep on emitting. इसका उतना काम नहीं है. When I'm pouring hot water, the outer ones का उतना काम नहीं है. Inner one का काम है. Inner one will not allow heat to go outside. It will emit inside. And if it emits also, there is a vacuum. And you have understood, these are not that hot that they will emit short IRs. So you can't cross the barrier. And thermos is very good. If you pour hot water at 8 o'clock at night up to morning 8 o'clock, एकदम गर्म, आप छू भी नहीं सकते, पर गर्म रहता है. Technique is so good. That in a nutshell concludes. You have nothing more here. So chapter is quite big. There are numericals where heat is equal to mc delta theta. हम वहां से start किए थे. It's the same chapter, thermal physics. Right now, if any one of you have your textbook, maybe Sastra and others, you all have it. Can you tell me now? We'll go back and ask, because we have to redesign our strategy. In your grade 9, up till what are you going to study in physics? First, come back from your side. Dhruv, in your grade 9, what is there in your grade 9 topic? See, I'll tell you, we are done with motion, forces, and energy. Let me just stop the recording, okay?